Miss.
Vaishnav,
Present, Miss.
Anjali,
Present, Miss.
and Shruti.
Present, Miss.
Okay. Now, Neeraj, please summarize what we have learned in the last class. Neeraj, I have told you, that I'll be asking the summary of what you have learned in the last class.
Miss.
Yeah, tell. You were dealing with what?
Optical fiber.
Hmm?
Optical fiber.
Okay, then what we have learned in optical fiber?
Advantage and disadvantage.
Okay, then what you have seen?
Oh,
അത് കഴിഞ്ഞിട്ട് എന്താ പഠിച്ചേ?
application.
Applications. Okay, then physical layer, you have seen what are the guided medias, right? Guided medias are of three types: twisted pair, coaxial cable, and the fiber optic cable. And you have studied what are the advantages and disadvantages of each one. Okay, and also what is the working principle of each one. Now, after that, what we have gone to, which layer we have gone?
Data link.
Data link layer. Now, what is the importance of data link layer? What is the function of data link layer?
Framing.
Framing, okay. So data link layer is responsible for node-to-node communication. One function, what it does is frame. Okay. Okay, thank you, Neeraj. So last class, what we have learned is we were dealing with data link layer. You can mute your mic. Okay. Data link layer and data link layer, the two main functions of data link layer, I have told it as one is the data link control. The other one is called the medium access control, right? Now this data link control, it includes functions like framing, flow control, error control. And last class you have seen what is frame. Now what is framing? Actually, the data unit in the data link layer, you can call it as a frame. Now framing, what it discusses how to organize the bits so that it can be passed to the physical layer. And this stream of bits is converted to suitable form and by the physical layer, and that will be transmitted through the medium. Okay, so framing, you can have two types of framing. What are the two types of framing? Drishya, I have told the two types of framing. What are the two types of framing? Drishya is there?
Yes, Miss.
Yes, tell. What are the two types of framing?
Fixed size framing.
Fixed size framing and the other one. If one is fixed, what will be the other? Portions on the variable size frame. Okay, so you can have two types of framing. One is fixed size framing and the other one is called the variable size framing. Now in fixed size framing, there is no boundary definition. Whatever is the size of the frame, that is nothing but the boundary or the delimiter. Now this variable size framing, you can have what you want to identify. Since the frame size is varying, you have to identify where is the starting of the frame and where is the starting of the next frame, right? Where is the ending as well as the starting of the next frame. So what you have to do is you have got two different approaches for this. That is where I have stopped in the last class. The one type of approach is called the character-oriented approach or the character-oriented protocol. The other one is called the bit-oriented protocol. One is called the character-oriented protocol, and the other one is called the bit-oriented protocol. Okay. Now, I hope you can see the slides. Can anyone answer? Yes or no?
Yes.
Yes, okay. Now, what is this character-oriented protocol? Now, in the diagram, you can see a frame. This is the frame that is represented in character-oriented protocol. You have got a flag field, you have got a header field, you have a trailer, you have the data, and another flag field. Okay, so this is the frame structure of character-oriented protocol. Now, this data that is to be carried, whatever is represented as data, they are the 8-bit characters. You just listen. Data that is to be carried are the 8-bit characters. Okay. Now you have got a header field also. Now what this header consists of, it carries the source and destination address. And if you have got any other control information, that is also in the header field. So I have told two fields. One is the data field. Data field is of 8-bit characters, and the second one is the header field. Now this header field, you can have the source address, destination address, and some control information. Okay, now the third field is called the trailer field. Now actually trailer field, what it carries is, it carries some error detection or error correction bits. It carries some error correction or error detection bits. You will be studying what is error correction and error detection in a while. So just understand they consist of some error detection or the error correction bits. Okay, now both are of 8 bits. Both the trailer as well as the header, all of them are the 8 bits. Now, I just told you should be able to identify where is the starting of the frame and where is the ending of the frame. So for that purpose, a flag field is inserted. So in order to separate one frame from the next, now what you are doing is you are attaching a 1 byte data. 1 byte is added. 1 byte means 8-bit is added at the beginning of the frame and also at the ending of the frame. Okay, so you can identify where it stops and where is the starting of the next frame. Understanding? So the frame structure of a character-oriented protocol, it consists of various fields. Those fields are the data field, the header, the trailer, then the flag fields. Okay, all of them are of 8 bits. Now, usually in character-oriented protocol, actually, when we were having only text format or the text, when we were doing text communication, this character-oriented protocol was very, very popular. That means it consists of only text. So sometimes there is a possibility that whatever be the characters in the text, that can be the characters in the flag also. It is possible, right? So you have to identify which is the flag field, which is the ending of the frame, or which is it consist of the data field. So in the beginning, the character-oriented protocol was used only for text communication. So whatever flag could be of any character other than the text information. So text information means I'm telling about the data. Okay, so the data, it consists of some characters, and other than whatever characters you are using in the data field, the flag field does not use that. Okay, so you should differentiate between the characters in the data field as well as the flag field. But that was always not possible when you are transmitting some audio or the video signals. Okay, so any part of the pattern that are used in the data can be a part of the flag also. So when you are sending some audio or video information, you will be making use of some pattern. Okay, so that pattern can happen to be present in the flag field also. So if this happens, what the receiver will think? So when a flag field errors, what happens when the character is same as that of the flag field if it is reaching? So the receiver identifies that the end has reached and the next data will be the starting of the next frame. Understanding? So what I told is character-oriented protocol, you can have the data field as well as the flag field. So earlier cases, when you were using this only for text communication, whatever characters you were using should not be used in the flag field. But that was always not possible when you were transmitting audio or video signals. So the pattern that was present in the data can be of a pattern present in the flag also. Both patterns will be similar sometimes. So if the flag pattern, if it appears in the data, what the receiver thinks that it has reached the end of the frame. Okay, so in order to distinguish, in order to solve this problem, a strategy was used. That is called it as the byte stuffing. This is the, just understand that is called it as the byte stuffing. So byte stuffing means the data section is stuffed with an extra byte. You can see in the diagram, you are getting data from the upper layer. Okay, suppose if the pattern of the flag, if it is existing in the data also, that is represented as flag in the data field. You just see the first row, data from the upper layer, you are making use, you are getting a pattern same as that of the flag. So their flag is written. So what happens if the flag pattern appears in the data? So what I told is you are going to stuff an extra byte, and that extra byte is called it as the escape character. Escape character are nothing but they are the predefined bit pattern. So you can see in the frame that is sent from the sender side, when you are having a data in the, when you look onto the data from the upper layer, you are having a flag pattern. So if the flag pattern appears, you are adding an extra byte, and that is called it as the escape character. Okay, so what happens when the receiver encounters an escape character? It understands, okay, the other part is not the flag, it is the part of the data only. So the receiver side, this escape character will be removed. Okay, and they understand that once the escape character is present, they understand that the next field will be the data. It is a part of the data itself. Okay, now what happens if escape comes in data? You just see the right part of the frame sent. So what happens if the text contains the escape character? So what the receiver will think, once escape is coming, so the next receiver thinks that, okay, the next part is the pattern same as that of the flag. Okay, so to make it look like a data, another escape character is inserted to it. So if one escape character is present in that data, what will happen is another escape byte is inserted or stuffed along with the data. So once the frame is received with an escape characters, what happens at the receiver side? They will remove that. Okay, so byte stuffing is nothing but it is the process of adding one extra byte whenever there is a flag or escape character in the text. Two things you are noticing. Byte stuffing, very, very important. Byte stuffing means, byte stuffing is the process of adding one extra byte. Extra byte means it is of 8 bits. Here, what is the extra byte I have added is the escape character. Okay, so whenever you are having a flag pattern in the data, you are attaching one escape byte, 1 byte of information. And whenever you are having an escape character in the data itself, you are inserting another escape character. Okay, so 2 bytes, extra 2 bytes you are inserting along with the data. Now at the receiver side, when you encounter this escape character, they will unstuff that and they will be making use of the data to the upper layer. Okay, so in order to better understand, I will just show you another diagram. You just understand. See, this is the example of byte stuffing. You are having the flag You are having the header, you are having the payload field. Payload field is nothing but the data. You have the trailer and you have the end of the frame, that is the flag. Okay. Now, in the original characters, now I'm just telling about the payload field only. You don't confuse with the other fields. Just assume the original characters, that is nothing but the data. Okay. Now, if a flag field appears in the data, what you have to do? You have to insert one extra byte. And that is after stuffing, what you are getting is the escape character, right? So escape character is inserted along with the flag. Now, what happens if escape comes in data? Towards the left hand side, you can just see an escape comes in the original characters. Now what happens? Another escape byte or the escape character is inserted along with the escape character. After stuffing, you have to add one more ESC character. Okay, now the third field, just look on to the third field. You are having an escape and you are having a flag. What happens at that time? For first escape, you are stuffing one escape. For one other flag, you are adding another escape. Now, if two escapes are coming in this data, then two escapes bits are stuffing along the data. So the meaning is you want to distinguish whether the data consists or data pattern is a if it remains same as that of the flag or if it's same remains as that of the escape character. So the receiver should not get confused whether the end of the frame has reached or it is the part of the data itself. So what you are doing is you are adding one extra byte whenever you are encountering a flag or an escape character in the text format, in the text or in the data. Understanding what is the meaning of byte stuffing? I repeat once again, byte stuffing means that is the process of adding one extra byte. Usually in character-oriented protocol, the frame format looks like what you are seeing in the diagram. You will be having a data field, you will be having an header field, trailer, and flags. Flag represents the beginning and the end of the frame. Okay. Now, in the earlier cases, suppose if the data, if it is of audio or if it is in the form of video or if it is the form of text, sometimes it is possible that whatever pattern you are selected for the flag appears in the data also. So the receiver should not get confused whether it is the end of the frame. So in order to avoid that problem or in order to fix that problem, you are making use of a strategy. What is that strategy is you are inserting one extra byte along with the data. So whenever you are having the same pattern as that of the flag in the data field, you are stuffing one escape character. So whenever the escape character comes, the receiver understands that it is that whatever is coming after this is a part of the data and it is not the end of the data frame. Understanding? Now, if an escape character, if it is present, is along with the data, then what the receiver will think, the other part will be the flag. Okay, so the receiver again, it should not get confused. So what you're doing is whenever an escape character, if it appears along with the data, you are inserting another extra byte that is called it as the escape character again. Okay, so the receiver understands that when two escapes are coming, it will be removing and stuffing the first escape and understands that it is the part of the information what is coming after this. Okay, so byte stuffing is the process of adding one extra byte. Byte means 8 bits whenever you are having a flag or an escape character in the data. Understood? What is byte stuffing? Yes or no? Understood? Can anyone answer what is byte stuffing? Atulya P. Atulya. Kavya.
Yes.
Yes. Understood the concept? What is byte stuffing?
Yes.
Yes. Okay. Atulya is not there. Atulya is showing present, but she is not answering.
Yes, miss.
Okay. So understood what is byte stuffing?
Yes.
Yes. Okay. Now you should just respond, okay? Because whenever my screen is in the presentation mode, so I cannot identify whether you are getting it or not. Okay, what I have told is the one type of approach in character-oriented protocol on variable size frame. Okay, so that is called it as the byte stuffing process. Okay, now we will go on to the next type of protocol that is called it as the bit-oriented protocol. Bit-oriented protocol means it is you are adding one extra bit along with the data. So what does that means? Now just look on to this frame. Now this is the frame that is being used in a bit-oriented protocol. Here also you will have the flag field, header field, data field, trailer and the flag field. Okay, so here you can see the data section of this frame is nothing but they are the sequence of bits. Okay, now you are having a special pattern for the flag here. Now, as you all can see, what is the pattern of the flag here? It is starts with 0. You have 6 consecutive ones and it ends with a 0 area. So that is the pattern of the flag that you are inserting along with the data. Along in the frame. Okay. So flag field, it is of 8 bits. It is the first bit, it starts with 0. You have consecutive 6 ones and again you are having a 0. And so that pattern is used in order to show the starting of the frame as well as the ending of the frame. Now, what happens if the flag pattern appears in the data? As you can see in the next diagram, what happens when a flag pattern appears along with the data? Now, you can see in this diagram, the topmost data, you are getting it from the upper layer. Now, whenever you are getting the data, it is nothing but, I have just told, they are the nothing but sequence of bits. Now, you can see the same pattern of the flag is appearing in the data also. So what you have to do is, you have to stuff one extra 0 whenever you are encountering 5 consecutive ones. Okay, so the flag field is 0, 6 consecutive ones and then a 0. So what you're doing here it is, you are, if in bit stuffing, what you're doing is, if a 0 comes and after 5 consecutive ones, you are adding an extra 0 along with this. So you can see in the diagram. So whenever you are having 5 consecutive ones, you are adding an extra 0. Okay, now what happens at the receiver side? So receiver understands that that is not the flag, it is a part of the data. So they will unstuff that 0 and it will pass the data to the upper layer. Okay, since you are inserting only a single bit, this is called as bit stuffing. The earlier one, what I told was byte stuffing. But here in bit-oriented protocol, you are attaching or you are stuffing only a single bit. So it is called it as bit stuffing. Okay, so this is about the bit-oriented protocol. So I will repeat once again, bit-oriented protocol, you will have a frame format. So the data section of that frame will be nothing but a sequence of bits. Now here you are having a special pattern for flag. that is nothing but 0 with 6 ones and then a 0. And that is acting as the boundary to define the beginning of the frame as well as the ending of the frame. Now, what happens if the same flag pattern, if it appears along with the data? How to inform the receiver that this is not the end of the frame? Okay, now what you are doing is you are stuffing one extra bit, only one single bit, in order to prevent the pattern to look like a flag. It should not assume that the whatever is coming it as is the end of the frame or it is the flag. So that process, that stuffing process is called it as bit stuffing. So how it is done is whenever you are having a 0 and 5 consecutive ones, you will be adding or you will be attaching one extra bit. That is the 0 bit. It is added. And at the receiver side, that will be unstuffed. Okay, so this is the framing concept. So framing, I have told two types of framing you are having. One is the fixed size framing. The other one is the variable size frame. So fixed size, you don't require a boundary to identify what is the end or the beginning of the frame. The boundary itself is the size is acting as the boundary there. But in variable size framing, you should be able to identify what is the starting of the frame as well as the ending of the frame. So you have got two approaches in this variable size framing. One is called the bit oriented approach. The other one is called the character oriented approach. Bit oriented approach, you are having a frame structure. You are making use of a sequence of bits to as a flag as well as the data. Okay, so the receiver should not confuse. Flag means end of the frame, okay, or beginning of the next frame. So the receiver should not get confused if the flag pattern or the flag bit, if it appears along with the data. So in order to avoid that problem, what you're doing is you are stuffing an extra bit. Okay, so that is called it as bit stuffing. But what happens in character-oriented protocol? Character-oriented protocol, you are inserting or stuffing one byte along with the data. One byte means 8 bits you are attaching along with the data. The meaning is whenever the pattern of the flag, if it appears along with the data, you are adding one extra byte, and that byte is called it as the escape character. That escape character is nothing but it is a predefined bit pattern. Now, if the data consists of escape pattern, another escape pattern also is inserted. So, byte stuffing, two things you are attaching. One is extra byte, 2 bytes you are attaching. One, if whenever is a flag is appearing along with the data, as well as the escape character is appearing along with the data. Okay, so this is very important, both bit stuffing as well as the byte stuffing. Understood the two concepts? What is character-oriented protocol? The other one is the bit-oriented protocol. What is byte stuffing as well as bit stuffing? Shruti? Understood? Understood? Okay. Jyotish?
Yes, miss.
Okay. So you have to read the concepts today only. Otherwise, and I'll be sending the notes also, because otherwise it is difficult for you to remember it. Okay, so I have just explained the first function of the data link control, that is called it as the frame. Okay, now we are moving to the second function of the data link layer or the data link control, and that is called it as flow control. Okay, so let me start with one slide. I hope you can see the slides. Yes or no?
Yes, Miss.
So just look onto this slides. This is what I have just told in the earlier class. The important responsibilities of data link layer are framing, line discipline, flow control, and error control. All these function together, they are called it as the data link control. Now we have finished the framing part, and again it has been divided into line discipline, flow control, and error control. Now line discipline, I'll just tell in a sentence because that is not there in your syllabus. Flow control and error control is very, very important. Now line discipline, it defines who should send now. That is, this is the concept of line discipline. If you are having two stations, who should start? How can one station be sure that the other is ready? Okay, so that is the concept, and that is done with an enquiry and an acknowledgement. You will be inquiring first, okay, whether the station is ready or when can I send the frame or data, whatever it is. And if I'm getting the acknowledgement from the receiver side, then I can start transmission process. Okay, so that is the concept of line discipline. Right. Now, we will move on to flow control mechanisms. Flow control means, see, you are following some set of procedures. I have to inform the sender. You are having a sender, you are having a receiver. So the receiver should be able to inform the sender that how much data it can accept. Or it is, you are having a set of procedures that tells the sender how much data it can transmit. It has to wait for an acknowledgement. Okay, so the meaning is whatever data is transmitting from the sender side, it should not overwhelm the receiver. Overwhelming means the receiver should be able to process whatever data you are sending from the sender side. Okay, but any receiver, whenever you are considering, they are having only a limited speed at which it can process the incoming data. It cannot process in a faster manner. So the receiving device must be able to inform the sending device before those limits are reached. And they can request whether to stop the transmission or whether they can send only few frames more. Okay, so flow control, that is the called it as flow control. It refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for an acknowledgement. If you are sending something, you should identify, you should be able to recognize that the data has reached the receiver safely, and that is done with an acknowledgement. Okay, so flow control are nothing but you are making use of a set of procedures that tells the sender how much data it can transmit before it must wait for an acknowledgement. Okay, now you can have two categories of flow control. So before that, I hope that flow control thing is clear for you. Flow control means whatever data is transmitting from the sender side, it should not, the receiver should be able to process that. The transmitting station, it will be sending it in a faster manner, but the process of transmission, what is happening at the receiver side will be in a slower manner. So the receiver should be able to inform the sender that in order to stop the process or in order to send a fewer frame. Okay, few frames more. Okay, so the incoming data, whatever is sending from the sender side, it should be checked and processed at the receiver. Understand? Whatever data you are sending from the sender side, it must be checked and processed at the receiver side. So the rate of such processing, it is often slower than the rate of transmission. That is what I just told just now. So the processing time is less than whatever is the rate of transmission. So in order to avoid that such situations, what the receiver will do is they will collect all these data and store it in a buffer. That is called it as a block of memory. And that is reserved. So that buffer is reserved for storing the incoming data bits until they are processed. That concept also you should remember. So flow control mechanisms are nothing but you are making use of some procedures, some set of procedures so that the sender sends the data such that the receiver is able to process that data. Okay, now you can have two categories of flow control. One is called the stop and wait protocol. The other one is called the sliding window protocol. Two categories of flow control mechanisms are there. One is called the stop and wait protocol. The other one is called the sliding window protocol. Now, what is this stop and wait protocol? The meaning only, it is there. Stop and wait means you are sending only one frame at a time. You are sending only one frame at a time. But when you are considering the sliding window, you can send several frames at a time. That is the difference between these two flow control mechanisms. One is stop and wait, means only one frame at a time. Sliding window means multiple frames at a time. Okay, now, what is the working principle of stop and wait protocol? You can see from the slide, at the center side, what it is doing is, it is transmitting one frame. Only one frame it is transmitting, and then it waits for an acknowledgement. Now, what happens at the receiver side? Whenever it receives a frame, it passes them up and transmits the acknowledgement. If the frame has reached the receiver in the proper order, then the receiver will be sending the acknowledgement. So what happens at the center side? When the acknowledgement arrives, it understands that, okay, the data has reached safely, then it will go up with the next frame. So this is the flow diagram of the stop and wait protocol. You can just see you are having a sender and you are having the receiver. Okay, so the sender is sending the data, then it will wait for an acknowledgement. So you can see in the left-hand side, the wait time is written. Okay, so once the acknowledgement is received from the receiving side, it will start transmitting the next data. So stop and wait means it is stopping, it is waiting for getting the acknowledgement, then only it starts the next transmission. Okay, now what is the advantage of this stop and wait protocol? Advantage is simplicity. Each frame, whatever you are sending from the sender side, is checked and acknowledged. Each frame, whatever you are sending, is checked and acknowledged before the next frame is sent. That is one advantage. That means it is simple. It is very simple. Error is avoided in this case. Okay, now what is the disadvantage of this stop and wait protocol? Here, it makes the transmission very slow. See, the data has to send, it is waiting until and unless it is not receiving the acknowledgement, the other data frame is not able to transmit. So the transmission is very, very slow in case of stop and wait protocol. Okay. So this is about the flow control, two important protocols. One is the stop and wait, and the one is the sliding wait. So I will just summarize what you have learned today. I have told about the framing concept, two types, fixed and variable. Variable, two approaches, bit-oriented approach, character-oriented approach. Bit-oriented, you are adding extra bit, that is called as bit stuffing. An extra zero is added along with the data whenever the flag pattern appears in the data. Okay, so at the receiver side, unstuffing takes place. But in character-oriented, extra 2 bytes you will be adding if you are finding an flag pattern as well as the escape pattern along with the data. So that byte, stuffing is called it as byte stuffing. and the pattern is escape character. Okay, so at the receiver side, that is unstuffed and the data is passed to the topmost layer. Next, I started with the flow control. Flow control means you are following some set of procedures that the center in sending the data from the center side towards the receiver side. Two types of mechanism. One is flow control, stop and wait, and the other one is slide. Okay, so we will meet in the 5th hour. That time I'll just tell what you have to do it in the afternoon session. Okay, thank you.